You've heard AM, you've heard FM. Now, tune into DM Radio, the world's longest running show about data. Each week, host Eric Kavanaugh interviews the brightest minds in the world of information management. Want to be on the show? Send an email to info@dmradio.biz. Now, here's your host, Eric Kavanaugh.
Once again to the longest running show in the world about data. It's called DM Radio. Yours truly here, Eric Kavanaugh. Very excited to be talking with a couple experts about data integration today. Faster, leaner, better, modern data integration. And, you know, folks, I have to say, we're in year 16 of DM Radio, and it was in year 1, way back in 2008, that I remember really trying to wrap my head around the amount of ETL that gets done in large organizations. And of course, that stands for extract, transform, load, which was the go-to way, still is, quite frankly, for many organizations, of moving data from one place to another. You extract it from one system, you transform it to fit a schema, to fit a particular target system, for example, like a data warehouse typically, and then you load it into the data warehouse. Well, about 16, 17 years ago, something came out called ELT, which is just a slight variation on that. You extract it from one system, you load it into the other system, and then you transform it there. Synopsys was a company that did that. They got bought by Oracle, as I recall. And that was clever. And it got very clever when we got into the world of the cloud. And the reason is because primarily transformations take compute power. Transformations can be difficult to do. They take time, they take effort. And in the cloud, you have this scale out capacity for compute. So you can just extract the data, load it into the cloud environment, and then where you've got all that compute, bang out all your transformations and get your data where it needs to go. Well, there's also something called data virtualization, I should say, which also is not new. Data virtualization has been around since 2005. I think a couple different vendors, Composite Software, a company called Denodo, they've been doing that for a long, long time. Informatica has some data virtualization functionality, as I recall as well. And historically, that was mostly in the form of intelligent caching. So you would figure out that this group of users is going to be doing queries on this data set, let's say the first of the month, for example, and you would provision that ahead of time. You'd make sure to load some data into a cache so it's there ready to go for these queries. It's pretty a manual process by and large, not terribly dynamic, but that in and of itself was great or good at certain things. But these days, there are much more robust versions of data virtualization. So we'll be hearing from Nick Golovin from Data Virtuality and also from Taylor McGrath of a company called Rivery. They also have a very interesting solution that took a demo probably a year and a half ago, and it was very complete, very comprehensive. It gives you a sort of management, a control plane to get data, to do the transformation, to visualize that, to point it in a certain direction. So you have kind of like your grand central station for data movement, and the engineers can see where it's coming from, where it's going. In the last couple of years, we've had this explosion of what's called data observability, and that's primarily geared around pipelines and data coming into a system. Is it coming in the way it's supposed to? Is it coming in at the right speed? Are we seeing the kind of values we normally want to see? It's also important because of Kubernetes, which we've talked about before on this show, which is sort of the de facto new way of building enterprise software, an amazing project that came out of Google and has really taken over. But with that long-winded introduction, let's bring in our first guest, Taylor McGrath from Rivery. You know, I love that platform, Taylor. It's very cool, and it gives that visual representation of what's happening. And that's what people need to wrap their heads around what's going on. It also just helps you get the job done. But tell us a bit about yourself and what Rivery has been working on.
Sure. Yeah. Hi, Eric. Hi, everyone. Happy to be here. So I'm Taylor McGrath. I am currently the VP of Solutions Engineering at Rivery. And Rivery is what we call a complete SaaS ELT platform. And I know that's like a lot of words jumbled into one phrase, but what it means is, or essentially a SaaS or fully managed software that kind of fully completes that like ELT journey. And really what the foundation or core of the product is data pipelines. So it really acts as your data pipeline hub for anything from ingestion to native sources to custom sources. and we operate in an ELT mindset. So getting that data into a cloud data warehouse, allowing for pushdown SQL, even now fully managed Python as well, serverless Python, and then also having the capability to leverage data pipelines to push data out of a data warehouse. So back into operational systems, for example.
So-called reverse ETL, right?
Right. Reverse ETL, I think, was the first kind of coinage. Now you hear like data activation, for example, is another phrase. But yeah, exactly.
Well, and this is, you bring up a really good point here. So this reverse ETL or data activation, I do like this concept of activating your data. Basically, what Taylor is talking about is that you pull all this data from your source systems, like your ERP system, your product system, your customer systems, for example, maybe web tracking, whatever it is you're trying to do. You pull that into a data warehouse or a data lake, or now there are lake houses. They have all kinds of interesting terms they're using to describe what they're doing. But the point is, in that environment, that's where you're doing your analysis. And that's great. And you learn things. But historically, the value of that was then generated by creating a dashboard, something that someone could look at and understand the business and then go make some manual change. Well, what you really want to do is take those insights and just fuse them back into the operational systems where work is getting done. And that's kind of the whole movement of this activation or reverse ETL, right?
Yeah, totally. I think like when you think about like traditional analytics, and there's still plenty of this, right? This is still kind of a foundation of like when a company starts their data journey, it's like, hey, I need data, I need some reports, I need some dashboards for like an executive level view of my company. Like who are our customers? What is our revenue? Like kind of these like basic questions to understand about what you're doing as a business. But then when you think about like taking it a step further and you hear like, powered by data, driven by data, like what does that mean? I think you think about it in the form of like workflows, like an operational employee, whether that's a salesperson or a manager of some sort, like in their day to day, how are they leveraging data? And with the traditional case, it might be something like, okay, I'm looking at a dashboard, I see some trend, I've done some analysis. Now I'm going to go back into my operational system, what I work in every day, maybe my CRM, my marketing platform, and do something, take some action. So I think what reverse ETL does is it kind of takes away the step of like the dashboard and puts everything into that operational system. But with that said, I'll say like this isn't necessarily a new concept whatsoever. I think for decades we've been sending data to operational systems. Now, albeit that might have been manual, that might have been with like homegrown code. But I think that the change here is really like when you think about the modern data stack and all these kind of categories that have come from that, and also the rise of SaaS products, I think this has naturally become its own category. And with kind of the take or stake that like cloud data warehouses now have in the data industry, like leveraging your source of truth that you're building there to send back to systems has never been like easier. So I think that's really like why we've seen a rise of this, and where we're seeing kind of all of this new, call it marketing, messaging, whatever, around activating your data, because I think it's never been more easy to do so.
Yeah, and I'll throw out an analogy here, and then we'll bring in Nick here in a second. But I remember doing an interview, 32 years ago, right out of college. I talked to a guy from the Illinois Department of Transportation, and we were talking about planning highways, right? So your data pipelines, that's like your highway through various suburbs, perhaps, to go get to your destination. It's coming from this location, it's going there, et cetera. And I remember him telling me that according to, I think, federal statute even, you're not allowed to plan for future traffic. You only have to plan for the traffic that you have now, which is a bit frustrating because they want to, get the job done at once. But you couldn't really do that. But now you kind of can. And the reason I mention this is because what happens when you open up the highways and you get more lanes, what happens? You get more cars. When things can go faster, when things can go easier, you get people using more and more and more data. So the more we open up these channels and the more we refine the pipelines and open up the capabilities to move data, the more data is going to be moved. What do you think?
That's for sure. I think, it's never been easier. And I think, like, honestly, for some companies, it's a blessing and a curse, right? Because we have, like it's very easy now with these SaaS platforms to spin up a trial, start doing things, point and click. But and even the kind of idea of ELT is like, let me just replicate my raw data and then deal with it downstream. So I do think there's kind of been this back and forth, especially of late with market in the state that it's in, of do we need all of our data, or we need to focus first and foremost on just the things that we need, just the lanes of the highway in your analogy, that we need for whatever traffic, because not all traffic, in the land of business value and getting business value from data, right? Like not all data is equally important. So when resources are not cheap, like they were, when money is not cheap, like it was 1-2 years ago, right. It's a different ballgame. But I think like the flexibility you get from these tools and the ease to set things up, I think is definitely an advantage, and is a fair argument when you're talking about even now, with the market in the state it's in, companies' budgets in the states that they're in. Yeah.
Right. Well, we have to keep all these things in mind. You make some really good points there. Not all data is created equal. Not all data has equal business value. And when budgets get tighter, we do have to pay more attention to where we're spending money. But that does get back to this observability stuff too. So we are getting closer and closer. It's really kind of fun to watch as we're getting more and more able to understand what things cost. Of course, in this new concept of data mesh that we'll be talking about in a not too distant show, part and parcel to all that is a strategy for being able to account for things better, for being able to understand how much things cost. And I'll use that as a segue to bring in Nick Golovin from Data Virtuality. Nick, you folks are doing this data virtualization stuff, and I think you're really sort of a poster child for data virtualization 2.0. But tell us a bit about yourself and your company and what you folks are able to do.
Yeah. So I'm the founder of Data Virtuality, and what we do is essentially based on the technology of data virtualization, and I can explain it in a technical way, but actually, Eric, you gave me a very nice way to, describe it in a non-technical way, because you were mentioning those lanes and all this traffic which goes around, those morning hours when everybody's driving to their offices. But what if some of the people were just able to work from home and not drive anywhere? And that's essentially what our company is about, because you also mentioned all this moving data is also costs. You need to build all those things, you need to move this stuff and so on. And what we do is we allow some data to work from home. Basically, we allow. Yeah, I mean, I love it too.
That's
brilliant. You gave it to me, and the more I think about it, the more I like it. So basically, it's a kind of teleworking for data, right? And as you mentioned, we didn't invent the technology of data virtualization. It was there before. So like this general idea of, we don't need to move all data. We can just talk to some data, connect to some data, and use it. It was there. But like I would say, like before data virtuality came around, it was a kind of pretty religious relationship between people who drive to office and people who work from home. So it was like it's either the one or the other. Right. So what we recognized is that to get the job done, to get people to do the work, to get data to do the work, some people still need to drive to the office. Maybe they they work for automotive, they work for some verticals where you need to be there. And sorry for jumping back and forth. And in the case of data, sometimes you cannot just connect to things where you need, for example, to historize the data over some time. Like, you need to build a slowly changing dimension, for example, or you need to bring the data over to cleanse them and transform them in a very special way. You need to bring them in. But for other data, you might just as well go and just get them from where they live. And like kind of continuing this analogy, which I mean, the more I talk, the more I love it, to be honest. And in the recent time, we also have cases where some special people may fly in. I mean, hopefully there'll be more in the future. And this is where we are talking about technologies for connecting data, such as streaming data or change data capture. And that's what essentially data virtuality is about making it possible for all those things to work together, to get the job done, all the data to get the job done, not really thinking about how it happens behind the scenes. So some people work from home, some data work from their source systems, some people are some data is stored in the central database, some data come in via stream and so on. And you can still, with our software, you can still model on top of all this and provide this to users and use cases in a uniform way.
And that is so important, because think about when this whole COVID thing struck and there were these lockdowns and all of a sudden you had all these people working from home. And I think one of the best aspects, the most positive things that came out of this was that a lot of companies figured out there are lots of jobs that really can be done from home, and that saves you time. It's time in the car going there, or time on the train, or whatever it is that you do. But the companies that understood their processes when that all happened, that really knew where data was and understood the relationship between business processes and people and data, well, they did okay. They were able to transition pretty quickly, but I guarantee you there were lots of companies that had never thought about the possibility of not being able to let people into the office to get access to their data. So from a networking perspective, from a provisioning perspective, from an access perspective, I mean, things went sideways in some pretty unpleasant ways, and there were some unhappy people for a while, right? They were pretty stressed out. Real quick, we got 1 minute. Go ahead, Nick.
Yeah, absolutely. So this is why it's really important to have this infrastructure and the right tools in place, prepared, so that those things can happen in the right way. Because I think those companies who were prepared from their tooling perspective, from their platforms, from whatever things they had there, they were doing very good. And the others who were not prepared, who didn't have the right tooling in place, they probably had some troubles along the way.
Yeah, and basically what happened is they had to put fires out. They had to go into code red and figure out new security protocols, figure out new networking protocols. I mean, there's a whole new space that's kind of opening up around cloud networking and really being able to provision the right kinds of solutions for the right kinds of workloads and the right kinds of organizations. And that can be complex stuff. But folks, don't touch that dial. I'll be right back. You are listening to DM Radio.
Welcome back to DM Radio. Here's your host, Eric Kavanaugh.
All right, folks, back here on DM Radio, talking to Taylor McGrath from Rivery and also to Nick Golovin of Data Virtuality. We're talking about data integration, getting data from source to target. Pretty important stuff. Years ago, where this all kind of started is we realized that we could not query operational systems like your ERP systems, enterprise resource planning, the systems that drive business, that actually track the delivery of products and all these kinds of things, which when you get to be a company like Nestle's, for example, there's a whole lot of product to track around. You got to stay on top of all that stuff. And you couldn't analyze those systems. You couldn't do an analytics on them because they weren't designed for that. Software, it's very important to understand the design points, what you're trying to build with software, because there are lots of ways you can do it, but to know what the kernel is, what you're really trying to accomplish is very important. And then you typically build on top of that. And then, of course, in the last few years, we saw lots of vendors coming in, refactoring their software to run on Kubernetes, which is container orchestration. It's interesting because we're talking data virtualization. A lot of people understand virtualization like VMware, which was the first wave of this stuff. And that was absolutely fascinating. And those folks came along because they realized that in data centers, a lot of these computers, the compute was not very active. So you're thinking to yourselves, wait, why are we, if the CPU usage is only like 10, 20%, that's not a good sign. Now we're paying for all this stuff and not getting the value. So virtualization came around as a way to optimize the compute and optimize really the value that you got from the hardware. And data virtualization, maybe I'll throw this over to Nick Golovin, since that's your space, that's really, it's analogous, but it's designed to optimize the value of your data by getting the right data to the right place at the right time without having to do so much of the heavy lifting. Is that about right, Nick?
Yeah, exactly. So it's actually a bit less about optimizing purely technical things like optimizing CPU usage. It's much more about optimizing the time to solution for the companies, and also the amount of work people need to get their work done. I mean, in a way, data virtualization has been around for a very long time, but we actually like to now, since this, as you did just now, it gets compared a lot to the server virtualization. We actually like more the analogy of data OS, kind of data operating system. And the analogy works like this: in on your laptop or on your mobile device, you have lots of technical pieces which somehow work together, do different things, have some data on them. But when you use your laptop, when you use your mobile device, you don't have to think about all those technical things, right? So you have some interface, and this interface, you can interact with it, do things, search for applications, and it can help get your work done, like get your applications running and so on. And this is why we like to think about what we do as a kind of data operating system, not in the sense like, it's a Linux clone or something, or you can run it on your laptop, but more in the sense of this analogy, you don't have to know what exactly technical parts you have there and how they talk to each other, but you can use it for your things without getting too technical about how it's exactly done behind the scenes.
Yeah, and that's really really important, because I think, let's get back to the cars analogy. I'll throw this over to you, and then we'll bring Taylor back in. You don't have to know how your car works to know that your car works, right? Like, you don't really have to care how the carburetor is doing, what the pistons are firing. I mean, you can if you want to get into the weeds and really understand it, that's great. But even that's getting harder these days, because the cars are very specialized, the engines are very specialized, you have special tools that you have to use to be able to work on them, to even open them up and get to them. For example, you need special tools to do that stuff. That's great for the mechanics. And we do sometimes want to understand the inner workings, the infrastructure, whether from an audit trail perspective or some other reason. But the business user doesn't care. The business user wants to be able to quickly grab a piece of data, throw it at some system, at some model or a schema or something, to kind of better understand it, and then really infuse that data, or, as Taylor is saying, activate the data by feeding it at a particular time to a particular business process, like a customer lifetime value score, for example. That's a very simple one, which anyone in a call center can really benefit from, because if you see that this is a very high value customer, you're going to be on your best behavior, and you're maybe going to deal with them getting a little bit upset with you. Whereas if it's a very low value customer, you're going to be like, I'm sorry, sir, there's nothing we can do for you. But the point is, you're enabling the business to act more intelligently without having to worry about which tool to use to get to that part of the engine. What do you think, Nick?
Yeah, absolutely. That's very right analogy. So you just drive, and you don't have to, you then have to push your gasoline through the tubes, so to say. Well, that's what you want to do at the end, right? Drive and not think about the workings inside. One thing where maybe this analogy could be a little bit extended, because with a car usually you just drive. So I mean, it's kind of one use case. But what we see in our situation, there's a multitude of use cases that are growing. So, for example, a customer lifetime value would be one score, which could probably be like historic value. But for example, our customers, I mean, customer, that's different, like customer in the sense of companies, they are also using us for other use cases. Over there are all kinds of dashboards or feeding the data into AI models, but there are also operational use cases. For example, calculating something which is called intraday liquidity risk, where by law you're obliged to give you live data, or near live data, or calculating a live credit score, for example, in an online store. So all these kinds of things. So it ranges from, it's not only about driving, it ranges from analytical to operational use cases, what people can do with the data
Yeah.
coming from such a platform.
Sure, and learning from the data too. I mean, you learn when you look at the data, you start to understand what can happen, and when you can visualize these things. And I'll throw this over to Taylor. I mean, there's one of my favorite philosophers, Ludwig Wittgenstein. He said, "Some things cannot be said; they must be shown." And his point was, at a certain point, when you try to articulate in words what a particular thing is, it can get kind of confusing. And if you don't believe me, folks, give yourself a little test. Just think about having to write down instructions for finding your keys and putting them in the car and turning it and putting the seatbelt on. It's going to take you a whole heck of a lot of words to do that. Or you could just show someone, here, I go like this and I go like that, boom. Oh, I get it now. So sometimes words are very cumbersome and also ambiguous, whereas visualization is much more clean and allows you to understand, okay, I'm pulling this data from here, I'm transforming it by enriching it with this customer lifetime value, then I'm delivering it over to this system over here. And when you can watch all that, well, that's when you can make sure the trains run on time and the customer service is good and they're acting on fresh information. And that's the other, I guess, curveball I'd throw at you, Taylor, is that for certain use cases, you must have fresh data. Sometimes yesterday's data is not good enough. And that's another one of these sort of characteristics or requirements that goes into designing your data pipelines and optimizing them to make sure that the ones that have to work in a certain time period are working in a certain time period, right, Taylor?
Yeah, totally. And I think I think Nick said it, like the differentiation between operational and analytical is key there, I think, because we're thinking analytical, right? That's probably something that can be like batch loaded. We're doing analytics at some time, we're digging into data, we're trying to find an answer or an insight. Whereas operational, plenty of times those are things that need to happen in real time or near real time, where a decision needs to be made. And it's crucial that happens at that certain point. And so even the example you gave, like with a call center, right? Like, and maybe the under the hood of getting the customer lifetime value is some analytics. Like maybe it's a recommendation engine or something that's happening, like some sort of AI modeling that's even getting us to that number. Or maybe more than a number, it's actually a recommendation that we're giving a call agent to say, like, hey, because of XYZ, like this is the talk track you should use with this customer. Maybe it's that smart. But like in a phone call, right, that needs to be real time. So what that means is kind of all the pieces of the puzzle that build to that need to also be near real time in terms of kind of already having the data or getting in real time, streams of data, but then also being able to do, and this is something that I think is still very much evolving and there's been strides made recent, is like, transformations in real time, right? Like what that means is you actually have to retain some form of state of the data to be able to transform it. And so, yeah, I think from what I've seen, even over the last year, there's been crazy developments around kind of how this can be done and also how easily it can be done, right? And some of these kind of tools that are part of the modern data stack that now like your kind of regular old data practitioners are doing. And what that means is that now, right, the tools and the things we're using to do these traditional analytics, it's becoming more and more of a Venn diagram or crossover into the operational world in terms of there's terms out there like operational analytics where like there's a combination of what you're doing is operational, but really like it's analytical in essence, where you're doing some sort of like analytics under the hood to even get you to that operational answer.
Yeah. And, you brought up, I think one of you brought this up, and it's a good topic to dive into, which is streaming. So also you have data streams. There's Kafka, of course, which came out of LinkedIn, but there's also Apache Flink, Apache Pulsar. There's some other data streaming vendors out there, which, Nick, I'll throw it to you first. It really is a different paradigm. So with Kafka, you set up these topics. And I remember the first time I learned about this, I was like, what a fascinating way to solve the problem. So historically, we would do all these point-to-point solutions. I'm going to pull data from my ERP. I'm going to target it into the data warehouse, make sure that all works. Now I can do my analysis. Well, with streaming, any number of subscribers can log in and capture that stream. So it's not, you got one stream going out and possibly 5 subscribers to it. That's a different model. That's sort of a hub and spoke model, but it also is different in a multitude of different ways, like how you can track it, how it lands, what it looks like. This is a whole new way of doing things. And from my experience, it has mostly been used in net new use case. In other words, I don't see too much of streaming being used to replace what was being done with ETL or ELT. But Nick, what do you think?
Yeah, I love this how you call it net new use case. So I've never heard this used, but that I think that hits the nail. I think this technology is great, and it's absolutely a great fit for many use cases. And I think because of its technological greatness, I mean technological wow, it certainly swing a kind of pendulum to the direction of like let's stream everything.
Right.
But I think like not trying to diminish the streaming technology in any way. Again, I think that's great, has a great future. I think that probably things will get into a situation which is somewhat similar to what happened to NoSQL databases back then, when like MongoDB and other databases emerged. Like everybody was like, wow, we don't need SQL, let's just do everything like non-relational, brave new world. But at the end of the day, it turned out there are great use cases for NoSQL databases, but there are still a huge number of use cases for SQL databases. The pendulum swung back at some point of time, and there is some equilibrium basically. And I think this will also happen to streaming. It will take a very strong position, but among many other technologies which are needed, for the modern world to work, because now you have SQL database, you have NoSQL databases, and you have streaming. Everything will be fit for purpose.
Yeah. And you bring up an excellent point here, which is the variety of solutions you can use these days. 25, 30 years ago, you had like 4 major databases that you would choose from. Now we've got hundreds, I mean, quite literally hundreds of different database applications. And the reason that happened is because there are very specific use cases. There are very specific reasons why companies wanted them. And of course, companies like Facebook rolled their own. They looked around, they're like, well, there's nothing we can use off the shelf that's going to solve these problems. So they had to roll their own, which they did at scale, right? Because with companies like Facebook and LinkedIn and Instagram, the scale, the just raw amount of data flying around there is just off the charts. Like you're not going to use an Access database to rock that world, man. It's going to fall over and just die. It'll just go, it'll say, please don't do that to me. So what that did is it frankly created an amazing opportunity for companies like Rivery. I remember taking a look at what those folks are doing, and also, of course, data virtuality as well, because in this highly heterogeneous world, you must have some management layer, some management platform for being able to go source to target, build your pipelines, look at the pipelines. And I think in the next segment, maybe we'll get into a real deep topic that I've always wondered about, which is visibility across those pipelines. How much are you moving the same data too many times unnecessarily? Is there redundancy? But folks, we'll get that after the break. You're listening to DM Radio.
Welcome back to DM Radio. Here's your host, Eric Kavanaugh.
All right, folks, back here on DM Radio, talking to Taylor McGrath from Rivery and Nick Golovin from Data Virtuality. And Nick, I'll throw it over to you. We were just chatting in the break there about getting the strategic view of data usage. And, what's kind of interesting here is that machines can monitor stuff so much more effectively than humans can. And there are a lot of different things that we do as humans that we probably don't even notice we're doing until some machine points it out. And we're kind of getting there these days, in part because of all these devices we have, like your phone. When it shows you screen time, it says, okay, this is how much time you spent on email. This is how much time you spent in text messaging. This is how much time he spent on YouTube, right? Which is like, wow, it's a reflection back of what we've done by virtue of what we were actually doing the whole time, right? Because the phone's with you all the time. And so it's like an observability engine in and of itself, right? So it's interesting. We are getting better at that, but I think you have some capabilities for noticing when joins happen often or when data gets aggregated often. And that's really what you want to do with data virtualization is recognize the patterns, be able to predict demands, access demands basically, and provision that dynamically, right?
Yeah, exactly. But it also works the other way around, because this same information can help and determine when things are not needed anymore. And this is basically, this is where you can use the same information about usage patterns to store data, but also to remove them from the storage.
Yeah, that's a really big deal too. It's a big deal for lots of different reasons. One of which, that's like cars that have been, that died and are on the side of the highway. That's why the trucks come out and get those cars and tow them away. Like, all right, let's get this out of here, because you're blocking up the traffic. And you also run the risk of people using it when they shouldn't be using it. Maybe, Taylor, I'll throw this one over to you. Usage patterns and understanding usage patterns is important for lots of reasons. One of which, of course, is just making sure that people get the data they want, but also knowing when to retire data, knowing when to move it to cold storage, for example, knowing when to maybe even delete it after 7 years or whatever the time frame is. There are certain industries like insurance and healthcare and others where you are required to keep it for a period of time. And then as soon as you're not required to keep it, they want to get rid of it, not just for the cost, but for the liability as well. Right, Taylor?
Yeah, for sure. I think like there's kind of a recent trend in like what's called, like, for the cost example, it's called like FinOps or
FinOps,
financial. Right. And I think a huge thing of that is like, okay, let's actually look at our metadata, look at our usage data, see what's actually being used, because at least at a very high level, we can make assumptions that maybe that has some value, right, if it's being used. And work backwards from there and kind of say, okay, of the things that aren't being used, let's try turning those off. Like over the break, we were talking about like the age old, just turn everything off and see who screams about it. And so I think, there's definitely now with so much data, and when you have a lot of data, there's also, metadata. And I think that's super important in like analysis of systems, right? Is like the metadata of what users are doing and what's happening with data sets. And that's kind of, I think, where like observability tools and even catalog and lineage tools come in, because you can really get into the metadata of what's happening when it comes, everything from like end user consumption to even what systems is this data going to even within my warehouse, what's being used in terms of what are people querying, and then impact analysis of like what tables update what tables, like kind of the whole visual of the flow of kind of this like spider web of things that happens, and understanding like when we need to reel it in, whether it's money wise or just there's a wild west of things, people don't know where to go. I think there's multiple reasons for kind of trying to rein back in. I don't know if tech debt is the word, but rein back in kind of all the things that have been built over years and years and years, especially at large enterprises.
Right.
It's a crazy, daunting task.
Well, and I think we're also, you had mentioned catalogs way back when, early in the show. I think it was actually during the 5-minute drill, Nick. And data catalogs, some of them are very, very robust in that they can dynamically scan your information architecture and come back and give you reports and show you things and say, okay, these are the field names in this source, these are the field names in that source. Being able to map those things and reconcile, that's very, very useful stuff. And we also mentioned briefly AI, artificial intelligence. So it's not just humans who are using data. It's not just applications. It's also these AI algorithms that are being used to build models, to build predictive models. And I think organizations really need to be careful where they point those algorithms, because if you don't know what data you have, you could be surfacing personally identifiable information. You could be surfacing trade secrets. You could be surfacing all kinds of things. So getting that real understanding, and there are some interesting vendors in that space right now too, data catalogs being one of them. That's extremely valuable to just know what is the topography, what is the map of our data that we're working with, and then slowly but surely you prioritize what you optimize, what you enrich, what you cleanse, et cetera. What do you think, Nick?
Yeah, absolutely. So I also think those topics of data catalog and also data governance, which is connected to this in a way, and all those security topics, that's very, very important. Be it for security, data protection reasons, or be it for data quality. So there are many reasons why things can be important. Our own take on this is that that's a huge space, the metadata space. It's a huge space. Our own mission in this space is to make one thing possible, which I think influences a lot of other things in a good and important way. So our mission in this regard is to make sure that the metadata live together with data and are served. Maybe they do not live together with data, but they are served to use cases together with right? Because there is a lot of work on the metadata side, and there is a lot of work on the data side. But what you have heard from customers, that things can get dangerous when they're not really connected, right? So metadata is living its own life in data catalog, and data is coming from somewhere else. And over time, this leads to situation where this is out of sync, and this brings issues of data quality, missing data protection, and all those other things. So the question is, how do we keep those things in sync? And our take is the best way is to give them to customers, to users, to use cases together.
Interesting. And you do have to play with this stuff to get to understand it. And, the people in the business who are closest to the data are the ones you want to have in these conversations to understand what this stuff means. But maybe, Taylor, I'll throw it over to you. I get back to this marshaling area or this management layer, because you don't want people to have to be just loading all sorts of different files, manually inspecting files. You want to have some window into those environments. And I took a briefing recently of Boomi, which is really a cloud integration type vendor. But what's cool, and I actually wanted to get into this, maybe we'll do this for the podcast bonus segment. What's cool now in the cloud is that you have all this API access, right? You used to set up ETL between this system and that system on-prem. And now with the web, it's mostly via API. And so you hit that API and you can see what is available to you. And I thought that was just a wonderful thing that they have. Can you talk about that a little bit, about the need to be able to see what's where and just have a visual metaphor for being able to explore all that stuff? It's very valuable to educate the business people and improve their data literacy, right, Taylor, real quick?
Yeah, definitely. I think a huge thing with softwares, especially ones that are built recently, right, is being what we call API first. So what that means is everything that you're building into a user interface, right, is also accessible programmatically, and a huge part of that is metadata. At least for a tool like Rivery, we are the movers, the plumbers of data. We don't retain the data itself, but we do retain metadata, right? And that's important to connect the dots between everything that people are doing inside our system. Where's my data coming from at the source? Then what tables do I load the raw data into? Then what are the transformed tables? Then what operating systems am I sending data back to if I'm doing that? And being able to see the whole picture, and then see even within our product, like the pipelines that do these things, is all retained through metadata. And being able to access that programmatically also means that essentially you could integrate that metadata with any other system, right? So with a cataloging tool, with a lineage tool, that maybe is already embedded in your company, in your enterprise company, you already have your data catalog, and you need to see what all these pipelines are doing.
Yeah, and the reason that matters, folks, real quick before the podcast bonus segment, is because that way when you build some new app, for example, you're able to very quickly replicate the experience that someone has in a different environment, in the portal, for example. So to enable that programmatic access, it gives you agility. It allows you to address business needs quickly. You've been listening to DM Radio.